Welcome back to the final model. Let's start again on the dashboard. Right now we are looking at case 5, the resource adequacy plus arbitrage structure. For today's lesson, let's switch over to case 8, which is our lender's ASC plus arbitrage case with a 20% haircut. In this lesson, we are going to model an auxiliary services contract. And this is the first time in the Deal Lab where we allocate BESS capacity to two dedicated revenue stacks, ASC plus merchant arbitrage. What's unique here in comparison to case 5 is that we allocate part of the battery's capacity to auxiliary services and the remaining capacity to merchant arbitrage, so it's a true split revenue structure. If you're new to this Deal Lab series, I recommend starting with part 1, where you can download the start file for free and build the model alongside me. Link is in the video description below. Let's jump over to the IAM. This is the final case of monetization pillar 1. You can see the key inputs for the ASC structure. Auxiliary services are based on a 1-hour BESS, capacity-based and paid in USD per kilowatt AC per month. We commit 120 megawatts to auxiliary services, which is 60% of the nameplate. The remaining 40% stays available for merchant arbitrage. And just like in the previous case, we are applying a 20% haircut on merchant arbitrage revenues in the debt-based case. Everything shown here flows directly into the input sheet of the model we are working with. Now back to our model checkpoint file from the previous lesson. We are on the inputs time independent sheet, and for case 8 you will see the same inputs reflected here. We can see ASC start date, contract term, price and escalation, as well as contractor capacity and whether we apply availability or curtailment adjustments. And below that are the merchant arbitrage inputs for the remaining capacity split. Everything is already structured. Our job is to link these inputs into operations and make the revenue engine work. Before we start modeling, one quick note. If you want to really understand what an auxiliary services contract is and how it behaves in the real world, take a moment to read the relevant section in the BESS secret sauce, which you downloaded at the start of the course. In short, ASC is a capacity style offtake, where the BESS gets paid for providing grid support services. Things like frequency response, spinning reserve, or voltage support. It's not paid per megawatt hour dispatched. It's a monthly, availability-based reliability payment tied to committed megawatts. That's all you need to know before we model it. Alright, let's move back into the operations sheet where we have left off in the last lesson. In the previous lesson we have modeled our merchant energy arbitrage revenue. And in this lesson, we will scroll back up and model our auxiliary services contract. And essentially, this is going to be a rather simple exercise because the structure is very similar to our full tolling agreement. So from a modeling standpoint, we'll make our life easy, scroll up to our capacity tolling agreement and pick up our first 3 formulas right here. So hit Control C, paste them here, Control V. And the very first formula we will have, as in the previous lessons, is our flag, whether this contract is turned on or off. So hit F2 here. We are referring to the proper timeline up here and to the dates from our inputs time independent sheet. And the switch, whether the contract is on or off, is also referenced properly. Let's check our prices on a real and nominal basis. Hit F2 here. So we are referring to 8 USD per kilowatt AC per month. However, we're still multiplying it with our CTA flag. So we have to adjust this reference right here to row 158. Right down here. Hit enter. And then let's check our nominal price. Hit F2. We are taking our price on a real basis and multiply it with an X lookup, which looks up our inflation index up here. So this is properly linked, which means we can take these 3 guys here, hit Control R, And now we already have the flag for the contract as well as the price on a real basis and nominal basis. Now let's move on to row 163, which is our contracted capacity before any adjustments. So let's see if we had the same row for our tolling agreement. And yes, the logic here was the same. So pick up this formula here, Control C, paste it here, hit F2, and here we are taking 60% of our total capacity, multiply it with our proper flag, and then let's scroll up to check the reference. And in row 47, we see our gross AC power in kilowatts AC. So we have, again, at the point of interconnection, 200 megawatts or 200,000 kilowatts AC available. And we take 60% of that. So hit enter, drag this one over, Control R. And you can see that the basis for our contract here will not be the 200,000, but rather the 120,000, because we have only contracted 60% of our overall capacity. And that's the key point here in comparison to the previous lesson, where we had 100% of the resource adequacy contracted, and 100% of that same capacity was overlaid with the merchant arbitrage. And in the previous lesson for the merchant arbitrage, we had a constraining price curve and constraining cycles per annum. Here we are not constrained. We can fully utilize the actual spread and maximize spreads per day. And you can also see that the cycles went up from 120 to 340 in this lesson. So spreads are higher and we'll have more cycles for arbitrage. Then let's move on to our nameplate adjustment, which we should have also modeled up here. So let's pick up this guy here, Control C, Control V, F2. Here we have an if error that we multiply with our flag. And that is going to be, as in the previous lesson, the AC deliverable energy per cycle according to our cap, which is 200 megawatt hours AC, because this time we only have a 1 hour battery, and the actual nameplate that we guarantee. Hit enter. Let's drag this guy over, Control R. And you can see that it never falls below 100%, although we have a merchant arbitrage case, and that is because we have already reflected our augmentations. Here in case 8, you can see that we have 20% of buffer to be restored once we are about to breach our minimum capacity. And the trigger is at 4% of headroom versus nameplate, which translates into the augmentations or augmentation trigger test that we have already modeled in previous lessons. So we have 2 augmentation events in year 2033 and 2040. Great. Then let's move on to the capacity after nameplate adjustment. And that is going to be simply our capacity before times this factor right here. Drag it over, Control R. And then the last thing we will do before we can actually figure out our final capacity that we get paid for is the 2 adjustments for availability and curtailment. And we have already modeled that multiple times in previous lessons. So let's pick up those 2 formulas here again from our capacity tolling agreement. Hit Control C, paste them here, hit F2 to check references. We are referring to the switch right here. Multiply the capacity after nameplate adjustment and multiply it with our availability factor up here. Hit enter. Let's check the reference for the curtailment. Again, referring to the switch as well as the capacity, this time after availability, and then multiplying it with 1 minus our curtailment assumption of 1%. Hit enter. And as in previous lessons, according to the switches here, we will get paid for curtailment events, but we will not get paid for unavailability events. So let's drag this one over, Control R. And for the applicable capacity for our ancillary services contract revenue, we will have a simple linkage again to row 167, Control R, which is going to be the final capacity that we actually get paid for with our nominal price. So for our revenue line, what we will do is take that capacity from row 168, multiply it with our nominal price in row 160. And now let's not forget some adjustments, because this here is in USD per kilowatt AC per month. So as in the previous lessons, we will have to multiply by 12 or months year. So let's refer to months year in the model file. And then here again, we have an output of 1,000 USD, while the price is modeled in US dollars directly. So what we'll also have to do is divide by 1,000 or 1,000. Hit enter, drag it over, Control R. And you can see that the final payment we will receive under the ancillary services contract for this structure, which is our debt base case, case 8, is roughly 277 million US dollars for 60% of our available capacity, and the remaining 40% we will get roughly 109 million in merchant arbitrage revenue. And for a short duration BESS, like a 1 hour battery, this structure can actually be quite attractive to both equity investors and debt providers. Equity investors can utilize upsides such as merchant arbitrage revenue, while they can also provide lenders with comfort in providing fixed capacity-based payments, which allows debt providers to lend with much more predictability in cash flows or CFETs, and can ultimately lead to a much higher leverage, so that equity investors can actually utilize a much higher equity IRR than if they would have realized under a full equity structure. Alright guys, this was it for this lesson, and in the next lesson we will model ancillary services on a merchant basis. See you there.